Hello everyone. From our previous sessions, now we all know that trigonometry is a type of math that we use when we want to work with sides and angle of a triangle. We have also learned to define the sides of a right angle triangle with respect to the given angle theta as opposite side, adjacent side and hypotenuse. And all the possible ratios of these three sides are known as trigonometric ratios, which we have defined as sine, cos, tan and so on. And we have also learnt about the complementary angles. The very important thing that we have seen is the trigonometric ratio value table for some specific angles that we use frequently in solving trigonometric questions. And so we have also learnt a simple trick to remember them. But being a mathematics learner, we would always be keen to know the logic behind the things that we learn and use in our life. And therefore here, even if we know the trick and value table, we would like to know the logic behind it. That is, why we say sine 0 is 0 and why not 1? Why sine 30 is 1 upon 2 and so on. Therefore, in this session we are going to understand how this value table is been derived. And we will learn in pair of complementary angles, that is 30-60, 45-45 and 0-90. But wait, what do we mean by an angle of 0 degree? 0 degree actually means no angle, that is simply a straight line. And can we think of having two 90 degrees angles in a right angle triangle? Well, answer is no, because two 90 degrees angle can never form a triangle. So how can we derive for 0 and 90 degrees angle? So let's first start with 0 and 90 degrees angles. And we consider a right angle triangle, say ABC, right angled at B. Angles A and C are complementary angles. So whenever we decrease any one of the two complementary angles, other angle increases and vice versa, and its opposite side decreases. So like this, if we go on decreasing angle A till it becomes 0 degree, we can observe that angle C is increasing and side BC becomes shorter and shorter. And at some point of time, when angle A is very small or equal to 0 degree, angle C is increasing, so it will be very close to 90 degrees, that is, will be equal to angle B. So this was all about the angles. Now if we observe the sides, when angle A is 0, side BC totally disappears, that is equal to 0. AB and AC overlap, that is they are equal. So this is what that will happen when we think of having an angle of 0 and 90 degrees in a right angle triangle. So if we concentrate first on 0 degrees angle and on the sides, then side BC is opposite side, AB is adjacent side and AC is hypotenuse. Now look at these trigonometric ratios. We can see that sine, cosec, tan and cot deals with the opposite side. And just now we have seen that when angle A is 0, its opposite side is 0. And thus we have the value of sine 0 and tan 0 as 0. Because if numerator is 0, the ratio itself is 0. And we say cosec 0 and cot 0 is not defined, because if denominator is 0, value of the ratio cannot be defined. And we have also seen that for 0 degrees angle, its adjacent side and hypotenuse are equal, which are the elements of cos and sec ratio. Thus we have defined the value of cos 0 and sec 0 as 1. Because if two things have same value, then their ratio will always be 1. I hope we all are getting it. Now, as 90 degrees angle is the complementary of 0 degree, hence opposite side of 0 is the adjacent for 90 and adjacent for 0 is the opposite side for 90 degrees angle. and hypotenuse will remain same. So for 90 degrees angle, here we say that the adjacent side is 0, opposite side and hypotenuse are equal. Thus we have the value of cot 90 and cos 90 as 0, tan 90 and sec 90 not defined, and sine 90, cosec 90 is 1. So this was the logic behind the trigonometric value of the pair of angles 0 and 90 degrees. Let's now move on to know for the pair of angles 30 and 60 degrees. Here we consider a triangle with all three angles and sides equal. So each angle will be of 60 degrees and say sides are of 1 unit. So as we cannot see any right angle triangle, we draw a perpendicular line from any one corner, say from corner C, so that it forms two right angles on its opposite side. And we can see two right angle triangles which are equal because their corresponding angles are same, and so sides are also equal. And as we have assumed side to be 1 unit, so this will be half. And as we all know that the length of perpendicular line can be found by using famous Pythagoras theorem, and which is equal to root 3 upon 2. Please note that as we have assumed all the sides of the triangle to be equal, so instead of 1, if we would have assumed sides to be 6 units or 10 units, so now if we look at the 30, 60 and 90 degrees triangle and concentrate on 30 degrees angle, we understand that every time opposite side of 30 degrees angle is half of the hypotenuse, or we can say hypotenuse is twice the opposite side. Therefore, we have the value of sine 30 as 1 upon 2 and cosec 30 as 2. Again, if we look at the adjacent side of 30 degrees, we observe that always it is root 3 times its opposite side, or we could also say opposite side is 1 upon root 3 times its adjacent side. And so we have defined cot 30 as root 3 and tan 30 as 1 upon root 3. Also, if we compare adjacent side of 30 degrees angle with the hypotenuse, then adjacent side is root 3 upon 2 times its hypotenuse. And so we have the value of cos 30 and sec 30. Similarly, we can do for its complementary angle 60 degrees and can get the values. Let's now start with the last part of this session, that is the derivation for 45 degrees angle. Once again we have a right angle triangle and say one angle is of 45 degrees. Other has to be of 45 degrees. So both the complementary angles are equal. Therefore, as we all know, their opposite sides are also equal, say 1 unit each. So length of hypotenuse will be equal to root 2. Once again, let me remind you all, as the two sides are equal, they will have any value but always equal. So we observe that for 45 degrees angle, adjacent side and opposite side are equal. Hypotenuse is always root 2 times its other two sides, or we could also say that the other two sides are 1 upon root 2 times its hypotenuse. Thus we have the value of cosec and sec for 45 degrees angle as root 2, sine and cos as 1 upon root 2, and as opposite side and adjacent side are equal, their ratio will always be 1. And so we have tan 45 and cot 45 as 1. Here we have finished with 45 degrees angle too. So this was the logic with which the trigonometric ratio values are derived and defined for specific angles. So friends, in trigonometry there are many more things to learn, and in the next session we are going to learn the most important concept, that is trigonometric identities.